All right, let's talk about linearity and symmetry here. So this video, this is kind of introduction video for like the entire lesson here, right? But this video, in this particular one, we are going to primarily talk about linearity. All right, we will talk about symmetry in one of the later videos, but we're gonna pretty much talk about linearity in this particular video. Once you have watched all the videos, you should be able to describe linearity and symmetries of functions basically from being able to look at, a graph, a table, or an equation, right? Um, for symmetry, it will mostly be from graphs, right? But for linearity, we can actually do it from all three of these different representations of functions. All right. So let's talk about what linearity is. All right. So before I go to the next slide, I want to kind of show you something here. And what I want to show you is if we take this, right, and we take the first four letters of this, we have the word line. And so it's really easy, at least in print, when you see the word linear to go, oh, that means we're talking about something that makes a straight line with no curves, no bends, just a line, right? The definition of a line, right? Going off in each direction. So when you hear somebody talking about a linear function, we're talking about something that graphically looks like a line on a table or an equation. For a table, it means that it's going to have a constant rate of change, and we'll look at that when we start looking at examples of that. But that means that when you kind of figure out the ratio from y to x, it's going to be the same for all of the values, right? When you're talking about, how it's changing from one to the next, right? And then with an equation, it's really easy to see if something's linear, because if it's linear, your x has an exponent of +1 all the time, and can be written in our slope-intercept form. And so we will talk about that. Let's move on. All right. So kind of just highlighted these points, but graph is a single straight line. All right. So we talked about that, but that's the easiest way to tell if something's linear, right? So on this one, like this, something like this would be an example of a linear equation, right? Something like this would be considered linear, right? We just have two different examples. This one has positive slope, this one has a negative slope, right? But they're both linear, they're both regular representations of it, all right? And then the table would show a constant rate of change, which we discussed, and then an equation can be written in slope-intercept form. So you'll notice always in this form that x always has an exponent of 1. All right. So if you see anything that's like, y equals x squared, right? That's a big no because of that, right? So you're looking for something that has an exponent of 1 whenever you're talking about how the equations are written. And then nonlinear is basically everything else, more or less, right? So you're looking at the graph is not a single straight line, right? And it's single straight line. So even if you have like something like an absolute value function, which gives you like a v, which is made up of two straight lines, or a piecewise function where you have something that like looks like this, even though it's made up of straight lines, it's not a single straight line, right? So that single is really important. All right. A table will show different rates of change, right? So it's non-constant. It means it's not the same. All right. So that's what constant, means the same. So not the same, right? And then the equation can't be written in this form. All right. And so pretty much anything that's a curve, right? So you'll see, we'll get into this later, right? You'll see things like parabolas like this, right? That's a nonlinear. We'll also see some things later on when we start talking about cubic functions that look like, something like this, right? And those are nonlinear functions. So, I mean, they're cool, but they're not straight lines. They can be a continuous line, but it's not straight, right? So it's got to be single straight line for it to be linear, and everything else pretty much is going to be nonlinear. Okay, let's leave it at that for this video, and then when we get back, we're going to start looking at some examples of linear and nonlinear equations, all right, and functions. Thanks.